My name is James Lewicki. I am a staff scientist here at Lawrence Livermore National Lab. I came here 8 years ago from the UK. I have a specialty in polymer physics and polymer degradation, and I joined the lab to work on various different programs related to polymer aging, performance, lifetime assessment, and materials development. I have been working on for the last 3 years now, and currently working on a technology to 3D print carbon fiber composite materials. Carbon fiber is great. It's stiff, it's strong, it's light. You can only make a few shapes at the moment. You can make tubes, you can make things that look like bathtubs, or you can make flat sheets. And even making those is costly and expensive. But with 3D printing and the right chemistry to back it up, you could potentially print anything out of carbon fiber. We're building these sorts of parts, or would be building these parts for a range of different customers. One of those customer bases would be aerospace. Weight matters when you're building planes, when you're building spaceships, when you're building satellites. Every pound counts. It costs, I believe, over $3,500 to launch a kilogram into space. And lightweighting is a big part of the technology development. If you could make reliable and complex carbon fiber structural parts, then one of the first customers would be definitely the aerospace industry. I would see CubeSats as a potential area. Because of the orthotropic nature of the parts as well, you can make these 3D printed materials right now which conduct heat in one direction and insulate in another. I could see making plane wings out of carbon fibers, or turbine blades which are thermoreflective in one area but conduct heat in another. So think about purposely channeling heat through an airframe. We have developmental single nozzle printer systems right now to push this over the hill and get it up to those complex parts I was talking about. We'll need a next generation of printing system, which is something beyond a modified direct ink writer. And to do that, we need new engineering design, we need new investment in more complex technologies. We have many different plans which we would like to realize, but that's really only going to happen if we can find an effective partner, I think, to help us do that. We have an amazing team of people working in this project. It's very multidisciplinary. We have chemists, engineers, computational scientists, and very experienced technical staff members. We also collaborate with the University of Illinois. And so the reason the team works is because we have a very diverse group of people with very different sets of skills. Optimistically, I would say that within 5 years, we could be 3D printing really complex, really high performance carbon fiber parts, which have comparable strength to steel at significantly lower density and are more reliable than the current generation of carbon fiber materials you have today. Everyone always talks about space elevators and you know, towers of diamond and you know, carbon nanotubes, but carbon fiber is a wonderful material. It's already amazing, and it's already been transformative despite those huge hindrances that you have in it. If you can remove those design constraints with something like this technology, then you could potentially build just about anything out of carbon fiber. And given its fundamental material property set, if you could build everything out of carbon fiber, you probably should. You know, that's the way I see it.